Hello, now we are going to discuss transitive relation. What is the transitive relation? So simply let's see first their definition. What is the condition transitive relation? If A comma B belongs to R and B comma C belongs to R, that implies that A comma C also belongs to R. This type of relation is known as transitive relation. What is here? A comma B, B comma C means here second element should come here first. Then first and third also should be paired in same manner. Then this type of relation is known as transitive relation. Let's see one small example. Then we will discuss little more. Suppose set A is there. 1, 2, 3. If you are going to write the relation R from there, what should write? 1 comma 2, 2 comma 3. Then what should be there? 1 comma 3. See, 1 comma 2, 2 comma 3, 1 comma 3. First and third also there. Then this type of relation is known as transitive relation. So now we have learned all three type of relation: reflexive relation, symmetric relation, and transitive relation. So now if any here in transitive relation we can say empty set. Empty relation is also transitive relation. Empty relation is also transitive relation. Transitive relation means if there is empty relation in set A, R from R to R, then that is also transitive relation. What we have to check? If A comma B belongs to R, B comma C. If A comma B not belongs to R, why to check other? Means what? Empty relation also will be transitive relation. Now we have learned all three type of relation. What is that? Reflexive, symmetric, and transitive. We have learned reflexive and symmetric and transitive. If any relation which satisfy all three criteria, means it is reflexive, it is symmetric, as well as it is transitive, then that relation is known as as equivalence relation. Equivalence relation. If any relation which satisfy all three criteria, then that type of relation is known as equivalence relation. Means reflexive should be reflexive, should be symmetric, it should be transitive. Now we have seen all these three type of relation. So let's see some previous year JEE question based on this topic. So we are going to check this 2025 January session. There is one question. What it said? It is defined. One relation is defined. Defined relation is that. Defined relation on the interval interval 0 to pi by 2 open interval by x or y, means x related to y, if and only if sec square x minus tan square y equal to 1, then R is here four options is given. First one, both reflexive and transitive but not symmetric. Reflexive, transitive but not symmetric. Second one is given an equivalence relation. Third option is given reflexive, means it is reflexive but not symmetric, not transitive. Fourth option is given both reflexive and symmetric but not transitive. Let's check which option is correct. So we know that for reflexive x comma x belongs to R. for all x belongs to domain. So what is given? 0 to pi by 2. So just why we have taken pi by 2? Because tan pi by 2 infinite came, so we cannot check. So we cannot take pi by 2. 0 to pi by 2 we have to take only value. So first condition we are going to check. So what we can write this way? This we can write this way. Sec square x equal to 1 plus tan square y. If you put in the place of y also x, what you will get? Sec square x equal to 1 plus tan square x. And we know that 1 plus tan square x, what? Sec square x. So what we are getting? Sec square x equal to sec square x. For all x belongs to 0 to pi by 2. So this is reflexive relation, because it will satisfy. Now we are going for symmetric relation. Symmetric relation, what it says? If x comma y belongs to R, that implies y comma x also should belongs to R. Then that type of relation is called symmetric relation. So let's check it here. First relation is given sec square x. Here sec square x equal to 1 plus tan square y. Now we are going to replace x with y, y with x. So what it will come? Here it will come sec square y equal to what? 1 plus tan square x. We know that sec square y equal to what? Sec square x. See, from this equation, sec square y, suppose this is equation first, it is equation second. We can simplify this more. What we can do? See, 1 plus tan square x, what we can do? 1 plus tan square x is sec square x. We know that. So what we can write? Sec square y equal to sec square x. And sec square x, we know that from equation first and second, what we can do? See, sec square x equal to 1 plus tan square y and sec square y. Sec square y equal to 1 plus tan square y. That is equal to what? Sec square x. It is the equation second. Let's assume third. From equation first and third, what we can use? Sec square x. Both equations are equal. So we can say if you replace x with y or y with x, nothing is changed. Means what? It is symmetric as well. So it is reflexive and symmetric as well. Now we are going to check it is transitive or not. Now transitive relation, what it said? If x comma y belongs to R, if x comma y belongs to R and y comma z belongs to R, that implies what? X comma z also belongs to R. X comma z also belongs to R. Then relation is known as transitive relation. So let's check for this. We know that is sec square x. So what we are getting? Sec square x equal to 1 plus tan square y. So x comma y belongs to R. Now what y comma z means, in the place of here x we have to put y, in the place of y we have to put z. So it is equation first. Now we can put here second y comma z. So what we will get? Sec square y equal to 1 plus tan square z. It is equation second. Now see what we have to prove. X comma z also belongs to R. Means what? See, sec square x equal to 1 plus tan square z. If we are able to prove this condition with the help of these two equations, then we can say it is transitive as well. How we can do? See this. Sec square y equal to what it is written 1 plus tan square z. And we know that sec square y, what we can write? 1 plus tan square y. 1 plus tan square y equal to what we can write? From equation second we are doing this operation. Equal to what it will come? 1 plus tan square z. 1 cancel. So from here what we can write? Tan square y equal to tan square z. Means in the place of tan square y we can write tan square z. So put this value in equation first. So what we are getting? sec square x equal to 1 plus tan square. In the place of y we have to write z. So this is equation third. Using first and second we are getting third. Means what? It is transitive also. So we have checked it is reflexive, symmetric as well as transitive. So which type of relation it is? Equivalence relation. Because we have seen that if relation is reflexive, symmetric as well as transitive, then we say this is equivalence relation. Let's see one more question based on this, then we will go for another topic. Next question, it is again 2025 January session, JEE Mains. It is given A equal to given 1, 2, 3, 4, 5, 6, 7. This is one set is given, and they say then the relation is defined this way: R equal to x comma y, means this xy should belongs to A, such that belongs to A, x comma y belongs to A cross A. A cross A is total 7 elements, so A cross A how many elements will come? 49. 7 7 is 49. And they say but such that x plus y equal to 7. This is the relation given, and option is given. First, it is symmetric, reflexive, transitive. So first, yes for standing. Let's write this way. I will write R for reflexive, yes for symmetric, 3 for transitive. So first option is given. It is symmetric but not reflexive, not transitive. Second one, not symmetric, not reflexive, but it is transitive. Third one, equivalence relation. Fourth one, it is reflexive, neither symmetric, not transitive. Let's check it. First, what we have to find? First, we have to find the relation where R ordered pair, where x plus y becomes 7, and x y what must be from here. So let's write first R. What is that? 1 will come. 1 plus 6 you can write, because 1 plus 6 7. So reverse also will can possible. 6 comma 1. Next, what we can write? 2 comma 5, 5 comma 2. After that, 3 comma 4, 4 comma 3. 5 comma 2, 2 comma 5 we are 5 comma 2. After that 3, 4 we have taken. Next 5 comma 2, 2 comma 5 we have written, 6 comma 1, 1 comma 6 we have written. So this is the total order pair will come relation R. Now we have to check it is reflexive, symmetric or not. It is very easy. Yes or no? See here, I told you for reflexive each and every element associated to itself. Here 7 elements, no element are here associated to itself, so it is not reflexive. If it is not reflexive, definitely it is not transitive as well. So what we have to check? So definitely this option is wrong, because it is equivalence relation. It is not reflexive. How it can be equivalence relation? So it is not reflexive. So first option also cannot be correct. Next we can check it. Next what? Now check symmetry. 1 comma 2, 6 comma 1. Here 1 comma 6, 6 comma 1, 2 comma 5, 5 comma 2, 3 comma 4, 4 comma 3. It is present. So it is symmetry. Now check transitive. See here, A comma B, B comma A comma B, B comma C. So what must be there? 1 comma 1 also must be present. Here 2 comma 5, 5 comma 2. So 2 2 also must be present. 3 comma 4, 4 comma 3, 3 3 also should be present. Then we can say it is transitive relation. But neither 1 1, not 2 2, not 3 3. It is not present. So we cannot say it is transitive relation. So which type of relation it is? It is only symmetric relation. So option second was correct here. It is neither reflexive, not transitive, but it is symmetric. So this way we can check which one is the relation: reflexive, symmetric, transitive, as well as equivalence relation. Thank you.